Hello viewers, in this video we are going to solve a problem in Thevenin's theorem, and the problem says we should use Thevenin's theorem to find the current in the 2.4 ohm resistor here. So this is a bridge network of resistors, and we have to find the current in this 2.4 ohm resistor. So as Thevenin's theorem goes, you have to find the Thevenin's voltage, which is an open circuit voltage here at where the resistor you want to find the current is. So first of all, in order to go about the Thevenin's theorem, you are supposed to remove the resistor which you have been asked to find the current through. Then after, you create an open circuit and you replace that open circuit with Thevenin's voltage, that is the VTH. So afterwards we find the Thevenin's resistance when we deactivate the sources. So let's see how we go about it. So we write our solution. So first of all, we have to take the resistor which you are going to find the current through out of the circuit and create an open circuit. So redraw the circuit and do that. So make sure that you remove the 2.4 ohm resistor, then you replace it with VTH. Then we redraw the circuit nicely. So we have our 3 ohm resistor here, our 10 volts here. You have our 5 ohm resistor, then the 3 ohm resistor, 3, then 3. So once you have our VTH, you are supposed to find the value of this virtual voltage which we have introduced here. So to find VTH, you are going to use the Kirchhoff's law, that is the KVL and the KCL, to find the value for this VTH. Now since we have a source here which is a 10 volt source, it's going to produce a current I, let's say I. So the current I will move up. When it reaches this junction, it will split into I1 and I2 here. So I1 will pass through this 3 ohm resistor, and upon reaching here, since there is no continuity here, it's an open circuit, it will skip and it will pass through this I3. So I1 will come and meet this I2 here, and the two of them will move together as I back again through this 5 ohm resistor. And when it reaches here too, since this place is discontinuous, or there is nothing here, so it will move here and come back to the source. So from here we can take a loop, and when you take different loops, you can find the value for I1 and I2 as well as the VTH. So first of all, how do you find the VTH? Let's take a loop where the VTH is in. So we assign a direction for the VTH. Let's say this. So the VTH is moving up. That's the direction of the current it will be producing. So if you take a loop in this way, if you take this loop, you realize that we are going to have the source voltage to be VTH, and from Kirchhoff's voltage law, we know that the source voltage is equal to the sum of the voltage drops, and there will be voltage drop across this 3 ohm as well as this 5 ohm resistor. So what will be the current through the 3 ohm? That will be the I1. We are going to get 3 multiplied by I1 plus, since it is following the same direction, plus 5 multiplied by I. So we can simplify the I here, because I is the same as I1 plus I2 from the KCL. So VTH is equal to 3I1 plus 5 open bracket I1 plus I2. So VTH will be equal to 8I1 plus 5I2. Let's put this one there. So once you have got this, let's find the values of I1 and I2, then we put it here to get our VTH. So to get the value of I1, let's take a loop. So taking this loop, if you take this loop, so if I take this direction, that is, we move here like that, I'm going to get the sum of the voltage drops to be equal to 0, since we don't have any source voltage. So I'm going to have a voltage drop across this 3, which is moving in this direction. So I'm going to get 3I1. Then after coming here, I took the loop this way. So coming here, a voltage drop across this 3 ohm also, and that is also 3I1 because the same current is passing through. Then finally, this place is moving against the direction of the current, so it will be minus 3I2 should be equal to 0. So I'll have my 6I1 minus 3I2 to be equal to 0. That gives me equation 2. So let's see. Let me find another equation so that I can find the value of I1 and I2. So from here, let's take another loop, a complete loop like this. We take from here, then here, then here, like that. It's a complete loop. So you can take the loop. The loop should not necessarily be a complete rectangle. So far as it's complete and there's no discontinuity, we can't take a loop like this, no, because there is a break here. So you can take a loop like this, then you also use the KVL to get another equation. So let's see, if I take this loop, I'm going to get 10, which is the source voltage, to be equal to the sum of the voltage drops. So one will be across this 3 ohm resistor, and the current through is I2. So plus 5 multiplied by I, because the current through is I. Then coming down, the same I will come and pass through this 3 ohm resistor. So we get plus 3I. So 10 will be equal to 3I2 plus 8I. But you know that I is the same as I1 plus I2 from KCL. That is Kirchhoff's current law. At this junction, I splits into I1 and I2. So we are going to get 10 to be equal to, this will be 8I plus 8I2. So here will be 11I2 plus 8I1. That gives me equation 3. So having 6I minus 3I2, then 10I2 plus 6I2 equals 10. I can find the values of I1 and I2. So I'll simply punch these two equations into the calculator to get the values of I1 and I2. Then after, I'll substitute it into the Thevenin's voltage equation as I have as equation 1 to get a value for the Thevenin's voltage. So what will be the value for the I1? So I1 is going to give us 1 over 3. So I1 will give us 1 over 3 amperes. Then I2 will give us 2 over 3 amperes. 2 over 3 amperes. So once we have the values for the I1 and I2, we can put it back here to get a value of the VTH, which is the Thevenin's voltage. So Thevenin's voltage VTH will simply be equal to 8 multiplied by 1 over 3. That is 8I1 plus 5I2, and I2 is 2 over 3 here. So this is equal to 8 over 3 plus 10 over 3. And you know that when you have the same base, the same denominator, you just add the numerator. So that will give us 18 over 3. And 18 over 3 will be equal to 6 volts. So the value for the VTH is equal to 6 volts. Now let's move straight to find the value for the VTH. To find the value for the RTH, which is the Thevenin's resistance. And to find the Thevenin's resistance, you have to deactivate all the sources. So the source that you are having here is a 10 volt source, and you have to deactivate it. That is, if it is a source, you create a short circuit. You remove the source and put a short circuit there. But if it is a current source, if you are going to create an open circuit, so this is a voltage source, so you are going to create a short circuit. So let's redraw it and deactivate the source. So we're going to have our 3, another 3, and here is our open. We put our RTH here. So we put RTH there, and this is our 5 ohm box again. So you have this. So here is our 3 ohm, 5 ohm, and 3 ohm. So where the source is, that is the 10 volt, you create a short circuit. Then after, the 3 ohm will follow. So this is 3 ohm. So once you have this, you have to find the total resistance across this open network. So this open terminals, you are going to find the total resistance, that is RTH, across this open terminals. So what do? Let's label the nodes A, B, C, and D. You can choose any letter of your choice, but we just want to label the nodes so that if you want to expand the resistor connection, you can see the various magnitudes very well. So at this point, we know that we have to find the total resistance across A and C, because that's where the RTH is. So we have to find the total resistance, or we have to arrange all the resistors within this terminal. So it's like us taking this back here and this back here practically. So this is a terminal, you put it back here. So you should have something like this. You should have something like this, and also something like this somewhere. Then you have the rest of the resistors being placed in between. So how do you go about it? So let's see, we have A. So we have point A here, then we open its terminal here. Then you have our point is in between and point C. So you have our point C, that is a node C. You label it C. You also push it somewhere here, nicely like that. So once we get this, we have to arrange the rest. So wherever A is connecting to, we have to draw all the other nodes. So from here we have this node B, A connecting to B. So let's draw that one up like this. So you can label this node as B. There is a resistor in between A and B. So this is a resistor, and that is 3 ohm. You draw it nicely. So from A we have also A to D. So you can bring that one to down here and label here D. And that is having magnitude 3 ohms also. Then you have B to C. So from B, that is from B to C. From B to C. So coming from B to C, you have to pass down here and pass here. And we are going to meet this resistor, which is 3 ohms. So you label it nicely. Here will be 3 ohms. Then after, we have D to C. D to C, we have 5 ohms. 5 ohms. Then finally B to D. B to D, which is 3 ohms. So you can use any letters to arrange all the resistors in between the two terminals AC. So once we get this, we can see that none of the resistors are in series nor in parallel. So we have to use the delta star transformation to simplify this resistor connection. So you introduce a star here, a star like this, so that we label here as our RA, our RB, and our RC. So once you get this, you find the values of RA, RB, and RC. So RA is in between the resistor 3 and 3. So what you do is that you are going to multiply the two resistors which RA is in between, that is 3 by 3, all over the sum of all the 3 resistors. So 3 plus 3 plus 3, and that's going to give me 9 over 9, which is 1 ohm. So from here we can say that RB, which is also between these 3, will have the same magnitude, which is 1 ohm, and finally RC, which is going to be 1 ohm, since all the resistors are of the same magnitude. So from here we can redraw the circuit as our A, which is something like this, moving up, coming to C, then C will come down, then we have something like this. So D, then here will be our C, and here will be our 3 ohm, 5 ohm, then here is going to be 1 ohm, 1 ohm, and 1 ohm, nicely. So after getting this, we can further simplify, because here you can see that 1 ohm is in series with this 3 ohm, this is also in series with this. Then after, this circuit is also equal to, let me draw a small circuit here, a simplified form. So I'll redraw this to get something like this, then I'll move up to get something like this, then to my C, the same as this. So here is my 1 ohm, and here is my A. Here you combine the 1 and the 3 ohm to get 4 ohms here. You get combine 1 and the 5 ohm to get 6 ohms here. So now 4 ohm and the 6 ohm are now in parallel. So to find a parallel combination, we are going to finally redraw the circuit as this, where C and A, finally the terminals are left or simplified this way. So here will be our 1 ohm, and here will be the parallel combination of 4 and 6. That will be 4 times 6 over 4 plus 6, and that will give us 24 over 10, which is the same as 2.4. So this will be 2.4 ohms, and our total resistance RT will be equal to 1 plus 2.4. That will give us 3.4 ohms. So therefore our RTH is equal to 3.4 ohms. Once we get the 3.4 ohms, we are left to find the current passing through the 2.4 ohms. So we draw the Thevenin's equivalent circuit. In Thevenin's equivalent circuit, we have the VTH as our source in that circuit, which is in series with the with the RTH, and also in series with the resistor RL, which you want to find the current through. So here will be my VTH. So this is the same as our 6 volt that we had. RTH is now 3.4. Then my RL was the 2.4 that was in the question. So 2.4. So to get a value for I, which is passing through the 2.4, I will be equal to the total voltage VTH over the total resistance RL plus RT, since they are in series, and this will be 6 over 2.4 plus 3.4, and this will give me 6 all over 5.8, and this will be equal to, so we punch this into the calculator, you have 6 over 5.8, and that will give me 1.034 amperes. So this is the current which is passing through the 2.4 ohm resistor, and this is the end of my video. Thanks for watching, and kindly subscribe and share.